Hello everyone, my name is Sylvain Rochon and I'm getting people to expand their human experience using cutting-edge technology. This week I wanted to do something more philosophical and scientific all at once. I often do that, but this is a little bit more philosophical, and you'll see what I mean. I want to talk about the dogma of the theory of evolution. It's something that constantly bothers me. Because a lot of scientists out there, and by extension, general population, because they listen to the scientists, are reasoning whatever they observe that is new and that is strange, and they by associating it, whatever change in a new species or whatever. By saying, well, it's evolution, it's random evolution that has caused this. And it's a blanket excuse or solution to an observation. It annoys me. It annoys me. So I wanted to spend a little bit of time to talk to you a little bit about why it annoys me and why I think the theory of evolution is such a... it's so prevalent. It is a theory. It has lots of research put into it. It's good to do proper research, and there's a lot of thought put into it, into how to structure, what we find in the soil, in archaeology, like bones, and what we see today. Where do things come from? It's great, and you're trying to put things together into a story that makes sense, that you can prove through experimentation and so on. Perfectly fine. I don't have any issue with the scientific method. The issue I have is by default just saying, well, it's like this, we can't explain it, but it must be evolution. Evolution being, just so you know, this is Charles Darwin's work. He enunciated the theory of evolution, saying that all species come from lesser species, essentially adapting over time by natural selection. So natural selection, a side definition, is if a part of the population is not equal, like we're not the same. Each individual human being is different, and some of us would adapt better to certain environments than others. And the typical example I use, which is really simple, is that if you're in a hot place where there's a lot of sun, you're better off with darker skin because you have more melanin and you have better protection against UV and so on. So people that have dark skin, if it's in survival mode, will tend to procreate more than people like me that's really white. And so dark-skinned individuals would essentially survive and pass along their genes. So that's natural selection. So fewer and fewer white folk, I guess, in this particular example, would survive the generations. Makes a lot of sense. This is something we've observed. This is what Darwin has observed in the Galapagos and everywhere he's researched. There's a bunch of evolutionists that are researching and finding proof of natural selection. It is a thing, no doubt about it. It's great. Now, where Darwin has projected, as he studied he's studied numerous species, and he said, well, if this actually occurs, and we're trying to explain where all these species come from that are very different, some of them are similar but like different in size, like significant differences with each other, well, it must have been successive generations of natural selection where certain traits are kept, and over time, over a long period of time, it becomes something very different. That's how we eventually come, like over millions of years, we go from bacteria to a wide variety of species, from whales to chimps to human beings to plants to everything you see, and it's all because of this evolution based on natural selection, just reproduction in generations in different environments, creating over like a lot amount of time, lots of time. Significant differences that I don't look like a tomato plant, but we have a common ancestor way back, and that's what it looks like. And you need a lot of time for this to happen. And this is all theory from 1869, I believe, where Darwin finally wrote his book after years and years of research. He didn't know anything about DNA. It was just basing himself on observations and some very good observation, and he theorized something. Now we're quite familiar with DNA and how it's structured. We know that like a huge amounts of DNA is actually useful. A very small amount codes for proteins, but there's a lot of the DNA that's used for lots of different things inside the cell, packing, transcription, methylation, different kinds of factors that are not protein-centric, but that are useful to the good functioning of the cell. Now, we'd think that because we have a better understanding of how DNA works, and we look at this genealogy of species that has been built over millions of years, that we'd be able to come up with a better explanation than what is sometimes called massive evolutionary leaps, because there's what's sometimes called the missing link as well. Like you have one species, and then the next step is this one here. But there's a lot of genetic changes to go from here to here. But if you base yourself on natural selection, you need to have all the subsequent generations that would, and these are small mutations like in genes, like 1 or 2 mutations maybe that are beneficial and that allow a species to survive better in a certain environment, that it passes it along. There's a whole slew of generations that have to survive with this particular 1 or 2 changes, very small, and then you have to have more beneficial changes, but then you have generations and generations of species that are just not found in fossils. And so there are other theories that have applied that say, well, in trying to reason, say, well, it's possible that over certain periods of time there was massive, very, very quick changes, and we just haven't found these bones yet. Because we do find just a small amount of bones in digs, and we find this one and this one, and then we can't find the others because it's the evolution has happened too fast. These are all attempts to justify, to find a reason to keep the theory of evolution the way it is. And part of the problem, or the real issue, is that we don't really have a good scientific replacement for the theory of evolution. So we keep coming back to it. So, well, it's kind of a mystery. We haven't found them, and then we kind of justify. We find reasons why things look the way they are, and then we look at genetic code now, and we look at the different species. Well, and we kind of try to justify, and some of it fits, some of it doesn't fit as well, but we still hang on to that theory. And at the same time, because this is all coming out, we have the deist faith, so people that believe in a God that say, this is because it's intelligent design, right? There's creation, it was put on the earth, it died to create fossils, and then the next generation was actually engineered to a new generation and tested out in the field, if you will, and some of them died, and because we know that some species actually become extinct. We have species that become extinct every year, so ultimately we'd find their bones, right? And some that do change traits over time due to natural selection a little bit, and that become a little bit different colors. This is what we can also observe. So these deist individuals and scientists are saying, well, this looks more and more like the work of what we would observe if an engineer would have created life, and then we're just finding the process of engineering from simple to more complex. Now, of course, this is also completely irrational scientifically, even though it makes logical sense. And I adhere to this theory of intelligent design because it fits a lot more what we see, but there's no proof of it, just like there's no proof of any God, and I don't believe there is a God at all. There's no proof of it, and there's no actual tangible proof that there is any intelligence that has created. I mean, there's no labs, we can't find anything that tangible, so it's a theory that explains the observations. The genetic code on its own can do natural selection the way it is. We know this, and we know that there's an experiment that we tried. I'm going to hop into the Linsky experiment with bacteria, where we're trying to test to see if there would be beneficial mutations in colonies of E. coli, Escherichia coli, a common bacteria that has a generation of about 20 minutes. Each 20 minutes, it's a new generation of bacteria, like they split. So they replicate very, very fast, and each 20 minutes, it's a generation. So we're trying to observe those. We've been doing it for 67,000 generations so far, and we're trying to see, well, how many beneficial mutations that would potentially equate to X amount of years in human years or animal years in number of generations, to kind of try to explain or discount in some, I suppose, the theory of evolution again. So that's a great experiment. I love it. And so far in 67,000 generations, the E. coli hasn't evolved into something weird. It's still E. coli. They are more adapted to their environment they were put in. They're a bit bigger. They thrive more. This is not unexpected to me, or I don't think any biologist is very surprised, because they were put in solutions that were probably very glucose rich and so on. So their own genetic code has adapted, just like if you come from north, you go to a hot country, like myself with my pale skin, I would be very stifled and uncomfortable the first number of days or weeks, but my body would adapt by switching on certain genes that allow me to feel cooler and feel better, and my biology processes things better. It kind of adapts naturally with our current genetic code. So the DNA of bacteria would actually do that, and we see this by bacteria adapting to certain chemicals, for example, and they exchange plasmids. They exchange genetic code with each other to try to adapt to environments. So that's not a mutation. That's the current code that kind of morphs itself and modifies and regulates itself to a different environment to create more survivability. So these 12 colonies of Linsky's experiment have been multiplying for 67,000 generations and over. That's equal to over 1.3 million years in human generations, because one generation is approximately 20 years. Now we live much longer, but back in the day we didn't live much longer than 20 to 25 years for a long time. So that's the average, and if you look at the time scale of what we find in bones, 1.3 plus million years ago, we were between Homo habilis and Homo erectus as far as our physiology, and these creatures didn't only have like one or two mutations different; they were significantly genetically different. As their morphology was very different, their brain was much smaller, and a lot of differences were there. And the only positive outcome of all these generations in the bacteria was one of the colonies developed the ability to process citrate instead of just glucose, which may actually it may not even be an actual mutation. I'm not sure about that. It may have been just the genes being activating in a certain way, a certain sequence, and then giving him the ability for the citrate to be reproduced. But even if it would be a real mutation that was beneficial, which is something that hasn't been seen before, I mean, you're talking about the equivalent of 1.3 million years. There's a single new processing pathway. You're not creating something different here. So how do you account for a whole planet's worth of millions of different species over 500 million years, I think, I think that's approximately it. The whole timeline since the before times, when 1.3 million years is equivalent, you just have one little mutation. It really doesn't compute for me, and so I think this is why I have a peeve. Like I would prefer if people would just keep the doubt. Keep what is provable. Natural selection is a thing. Let's talk about natural selection in classrooms. Let's talk about that. That's real and something that really happens, that is observable. We can test it. We've done it. But the evolution and like teaching that is, we instead of teaching it as a possible theory among potentially others, We teach it as dogma, as that this is how we came to be. Now, this is how we think we came to be. There's a big difference. Like I said before, I prefer the theory of intelligent design. There's no proof for it, and I don't think it's a god, so it means it has to be people, intelligent beings that would have come here, created life in sequence, and we are observing that work in the soil and the way it is, and that makes a lot more sense, even though we don't have a clue necessarily scientifically, at least, who they are. I have my own theories, I have my own ideas. That's great, but I guess that's the point. We have to keep our mind open to various theories to explain what we observe, and that's scientific progress. Keep the doubt in, and then eventually we'll figure things out. And maybe we'll discover what really happened, how we came to be, and how life is diverse and all that stuff. Maybe it will be some form of biological process over time. But it has to be shown to be that. Otherwise, it's just a theory. It's an idea. And maybe we will discover or be visited, for example, by extraterrestrials coming out. It's like, yeah, it was us, and here's the proof. Well, that's another way to go about it, to prove one theory or another. But until then, let's keep the doubt, guys. This is proper scientific progress in my mind, and process, and it's really important, as we can't fall into any kind of dogma, sticking to a certain idea just because a bunch of people are saying it. Doesn't mean it's real. Doesn't mean it's exactly what it is. A theory is as good as it may be until it is proven and validated by experimentation to be possible within the constraints and being tested. It remains just a theory that remains to be proven, and that's it. And that's my point for today. So hopefully it wasn't too hard for you philosophically, but I think that's really important. Let's keep to the facts. Let's keep. Doubt is not a problem. Believe you me, it's like that just raises more questions and more research, and that's what we want to do. All right, so that's going to be it for today. I will jump back probably next week with a purely scientific. I believe I will be talking about food and farming technologies, which has become really interesting over the last couple of years. So I'll be talking about that. In the meantime, enjoy your time thinking about, are you dogmatized or not? I don't know. Ciao for now.